Hello, and thanks for joining me today as we begin our discussion on the periodic table. So today we're going to get kind of a basic understanding of how the periodic table is laid out, along with a little bit of history of it. And then on the next video, it's kind of a two-part section. So the next video, we're going to look at some specifics and look at individual groups and elements and things of that nature. So for today, we're going to look at the importance of a guy named Mendeleev and his contribution to the table, and why that was a big deal. And then we're going to look at, you'll be able to identify important families of elements on the periodic table and kind of be able to explain why they are known as a family. And so, starting with our history, from the ancient Greeks, so the BC era up until about 1800, so a couple thousand years, we only knew about 14 elements. There were 14 known elements. In the next 10 years, 1800 to 1810, we doubled our number of elements. We're up to 28. And then by 1845, we were up to 45. So another 17 elements were figured out or discovered in those next 35 years. So a lot of growth between 1800 and 1845. And with that growth, we had to find a place to put them. And so instead of just making a big list of these things, there was initially a German chemist, Dobereiner, who noticed that there was an order to these. And so when bromine was discovered, he noticed that it had properties somewhere between chlorine and iodine. So we had these two elements already found, properties were already kind of established, and bromine kind of fit somewhere in between those two. And he found a couple other groups that did the same kind of thing. So he had calcium, strontium, and barium. That calcium had properties, strontium had similar ones, a little bit different, and barium kind of expanded them a little bit more. And same thing with sulfur, selenium, and tellurium. That they had similar properties that kind of were a progression. And he called these triads, being as there were three in each group, he called them triads. And we're going to fast forward. And we're going to end up at 1869. There's a Russian chemistry professor, Dmitry Mendeleev is the guy. And he took this understanding and this our current foundation of elements, and he was looking to help his students. What a nice guy. And so he took these elements and put them in a periodic table into a textbook. And what he did with them was arrange them by increasing atomic mass. And he said that if all elements are arranged in order of their atomic weights, a periodic repetition of properties is obtained. And so what he would do is he started with the smallest element, and then he put them out in order until the properties of this element repeated again. And so then he cut his list and started row 2. And went until properties repeated again, and we would row 3, so on and so forth. He ended up with a table that looked something like this. And so he had these different elements that, like here's hydrogen that didn't have anything else that was similar to it. But then we had lithium that acted in a similar fashion to hydrogen, so put it in the same column here. And then we had a list of elements. And then sodium repeated those same properties. And we got bigger, and so these repeated as well. If we put them by atomic weights, they kind of line up in a certain sense. And he found that these different things all correlated. And we've since built on that. So he built his by atomic mass. And so you'll notice there are holes here. So there's gaps. 21 is a gap. 18 is a gap. 36 is a gap. There's all these holes where we don't have elements at. And he saw these as opportunities. Not really a problem, but an opportunity. And so he could use the properties of the elements surrounding it to make a prediction about these holes. And he did that. So again, the holes aren't a problem. He used the properties to predict elements. And he actually predicted an element called exo-aluminum. And so this element, exo-aluminum, had properties similar to aluminum, and he used those properties to predict what this element was going to look like and how it was going to function. And I'm looking for aluminum's here. Okay, so if I look, we delete all of these. Aluminum is element 13. So element 21, he called exo-aluminum essentially. And he predicted all these properties for this element. And turns out he predicted these properties for the element that we know as gallium. And the guy that discovered gallium didn't do readings correctly, or something happened that Mendeleev said, your measurements for this substance are wrong, because based on my table, this is what it should be. So he predicted the melting point, the boiling point, and the atomic mass, and he was actually more correct than the guy that discovered the element, which is pretty crazy, but he was obsessive and made it all work. So we expand Mendeleev's table. So that was 1869. Fast forward, 1913. Moseley. Remember, Mendeleev arranged his by atomic mass. Moseley decided that if we looked at nuclear charge, or the number of protons, we could more clearly repeat those properties. Everything would line up exact. And so this is where we just developed this idea of periodic law. And so periodic law is the notion that properties of elements recur in a repeating pattern when arranged according to increasing atomic number. Basically, if you line things up by atomic number, the properties will eventually repeat themselves. Periodically, the same thing happens. And that's periodic law based on Moseley's table that lined them up by protons, which is how we line them up today. So your periodic table is based on your atomic number, which is equal to the number of protons. And that's how our table is arranged now. So we have hydrogens 1, helium's 2, 3, 4, so on and so forth. There are, I believe, 2 instances where this would be different should we arrange by atomic mass. One of them being tellurium and iodine would be flipped, and there was one other, I guess polonium and astatine would be flipped. I thought there was one more, but there are a couple instances where the bigger number, or the smaller number, comes after the bigger number. But so if you line it by atomic number, everything lines up perfectly. And when we talk about the periodic table, so there's a couple terms we're going to use to describe the periodic table. One of them is rows. Instead of calling them rows, we're going to call them periods. So a row on the periodic table is called a period. Think of I write a sentence. When you write a sentence, you write it in a horizontal fashion, and you end your sentence with a period. So periods run horizontally. There are 7 periods, numbered 1 through 7. They correspond to the 7 energy levels of an atom, those 7 electron energy levels. Your first period only has 2 elements. The second and third have 8, and everything after that has 18. Fourth and fifth have 18. But these are called periods. With your periods, your period also indicates your principal quantum number, which is just another way that we can identify electrons. So your principal quantum number is equal to the period of the element. So horizontal is called a period. If we have vertical columns, so vertical columns run up and down, we call these groups, or we call them families. There are 18 vertical columns on the periodic table. There's 2 types of periodic tables. There's the American version, which is has an A and a B version, which you see at the top. And the European version just goes straight 1 through 18. The international version is the 1 through 18 digits, and these correspond to Roman numerals. Everything's Roman numeral there. But these columns correspond to your number of valence electrons, which means they all act the same, which is why they're called a family. Some groups have common names. So group 1 is called your alkali metals, group 2 is your alkaline earth metals, group 17 is your halogens, and group 18 is your noble gases. These will be important. We'll reference these quite often in the coming days and throughout the year. So here's your table. Your alkali metals are column 1, alkaline earth is column 2, halogens are column 17, and noble gases are column 18. Alright, a real quick review. Make sure you can answer these questions, and then we'll continue this discussion in the next video, and we'll use this again throughout the rest of the year. So what is periodic law? Why was Mendeleev's periodic table such an important creation? How are periods and families different? And then what elements are known as halogens? So give me a couple examples of halogens. But get that done, and I look forward to working with you as we continue this semester. Thank you, and enjoy the rest of your day.